Okay, so on this question, we have a couple weird things going on. So we have these -1 powers. What's up with that, first off? Well, a -1 power, I don't know if you remember from earlier in the course, if you have anything, call it x or whatever, to the -1 power, that means 1 over x. Remember, negative powers are unhappy. I would say they're negative, like a negative person who's unhappy at their job. They want to jump to a new job. So they're negative power, they're unhappy, they want to jump down to the bottom, and then they're happy. Okay, so that's what's going on here. But careful, we can't just grab this guy and jump to the bottom like that. Why? Because of the adding, subtracting. So, so instead, what you have to do, this gets a little tricky here. You have to go like this. This is going to become 1/3. It's going to become 1/4. Then on the bottom, 1/3 minus 1/4, like so. So, right? So each of those little -1 power things becomes a fraction. And now, what do we have? Well, this is a complex fraction, meaning it's fractions over fractions. It's fractions over fractions. So what are we going to do with it? Well, when you have adding and subtracting, things are more complex. We've seen this a couple of times before, right? We already know that when you have adding, subtracting, you can't just cancel. You can't cancel added, subtracted items. Well, in the same way, you cannot flip added, subtracted items, meaning I can't do this. I can't just grab these guys, go, all right, just flip them up there, and it'll just be 3/1 minus 4/1, and then just change it to times. No, that's actually not true. Why? You think, well, isn't that what we do a lot of times? It is. If this was times and this was times, we would totally do that. That would be exactly the right thing to do. But so you can flip multiplied items, but you cannot flip added, subtracted, just like you cannot cancel added, subtracted. Why not? It's just simply not true. Sometimes it feels like math is just purposely trying to make hard rules, but really they're just following the truth. It's just, I could show you with number examples. It's just simply not true. Well, here, let me show you with this. I want you to see it's true. What if we had like 10, wait, that good one? Yeah, divided by 1/2 plus 1/2. What I do is I make up a really simple case where we know what the answer is, and then we can test out the rule. Now, what is this really equal to? Really, this is 10/1, right? Because 1/2 and 1/2 is 1. And what is 10 divided by 1? Well, it's just 10. So the answer to this is really 10, right? We can just see it. But what if you tried the rule? But the flip rule tells you, oh, make it 10 times 2/1 plus 2/1, right? Grab this on the bottom and flip it. That's just crazy wrong, right? 2 plus 2, right? This right here, 2. This is 10 times, right? 2/1 is just 2. You agree with me? This would be 2 plus 2 now, right? 2/1, 2/1. That's 10 times 4. That's 40 now. That's crazy. See how crazy that is? So that, let me just put a big, no, right? That shows it's just crazy. You with me? So you cannot flip added, subtracted items. Why? It's just not the truth. Math is not trying to just make hard rules. They're just following the truth. And you can see, right? 10 over 1/2 plus 1/2 is really 10/1. 1/2 and 1/2 is 1, is 10. If you try the flip thing, it's going to become 2/1, 2/1, which is 4. 2 plus 2, 4. 10 times 4 is 40. That's crazy. Not true, right? Not true. You can't do the flip thing. So, well, here, I shouldn't have crossed up the whole, well, yeah. So we cannot flip. So then what do we do? So let me rewrite the problem. Oh, crazy now. So I've spent a lot of time telling you what you can't do. What do you do then? Well, 1/3 plus 1/4, 1/3 minus 1/4. Instead, now I know you're used to factor, but not factoring here. Instead, multiply all the terms, top and bottom, by the LCD over 1. And what's the LCD means least common number. LCD equals 1 of each item under a small bar. 1 of each type of item, I should say. Type of item under a small bar. So we have a 3, a 4, a 3, and a 4. So what are we going to do? We're going to multiply top and bottom on this one by 3 times 4 over 1. 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 Does that make sense? That's the LCD over 1. Multiply all the terms, top and bottom, by the LCD over. Let me pause for a second there. That's a really different kind of step, huh? So do you see what we're doing? I multiplied all the terms, top and bottom, by LCD over 1. And what is the LCD? I just looked at them. What, 3, 4, 3, 4, right? You look at the items under the small bars, and you take 1 of each type of item that's under a small bar. So I said, well, look, we got a 3 and a 4, and then another 3 and a 4 under small bars. So I use 1 of each type. So I'm not going to use 2 3s. I'm not going to use 2 4s. I'm just going to use a single 3 and a single 4. And you put it over 1, right? LCD over 1. 3 times 4 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 over 1. Like that. And why do you do it to all the terms? Well, because we have to do the same thing to the top and the bottom so that we don't change the fraction. Right? Whatever you do to the top, all the terms of the top, you have to do to the bottom, all the terms on the bottom, so that you don't change the fraction. Okay, now what do we do from here? So step 1, you cannot flip added, subtracted items. Instead, do the multiply thing. Step 2, cross cancel. 3 cancels 3. 4 cancels 4. 3 cancels 3, and 4 cancels 4. So what's left over? Huh? Bring it on down. What's going to be left over is something much nicer. What's left over here is just the 4. Plus what's left over here is just the 3. What's left over here is just the 4. And what's left over here is just that 3. You with me? Right? If, for example, right here, it's just 3 times 1 over 1. The 1s don't do anything. You know, multiplying by 1, 3 times 1 is still just 3. Divided by 1 is still just 3. So all these 1s are really doing nothing. Right? Because when you multiply by 1, doesn't change anything. You divide by 1, doesn't change anything. So this is all that's left over. Much nicer, isn't it? And then we can finish it from there. What's that? That's just 7 over 1, which is just 7. We never leave 1s in the bottom. So that means that whole big, ugly mess just simplified to be 7. This is just a big, fancy way of saying 7, in other words. It just all boiled down to 7. Is that making sense? One more time. These -1 powers, what did they do? What do these -1 powers do? They flip. So 1/3, 1/4, 1/3, 1/4. They flip right where they're at. And then we cannot flip added, subtract items. We can't flip these guys up like we did other times. Instead, multiply all the terms top and bottom by LCD over 1. And then step 2, cross cancel. So we canceled. See how that made it nicer? That got rid of all, see how all these little denominators canceled out so that it was a much nicer problem. And then it's just 7. We cleaned it up. This is much cleaner than the original. And so there we go.